Hello everyone to my presentation about chaos engineering with Spring Boot. So the main goal of this presentation was actually to show you first as an introduction what actually chaos engineering is, what kind of problems we have in different setups. And you may say, well, we heard that people are doing that even, for example, with microservices. But actually, I would love to show you as well that chaos engineering is a practice which is quite important as well if you are not doing just microservices, because also like in traditional applications, it could be actually a huge benefit. So chaos engineering, probably as you see also from my picture on the right side, with the seminarming is a well-known term from Netflix. And we will just go and find out together what it's about, how you can do it in the end, and where to start. And probably also with the idea of using that in your Spring Boot application. So first, short introduction about myself. I'm Patrick, and I'm from Zurich, Switzerland. And I call myself a technical agile coach because usually I help teams develop software in a better quality and bring it faster to production. So that means like a lot of coaching, pairing, architecture, solution design, and so on is involved, also training as well. And you can imagine if you do this, Spring Boot Chaos Monkey, or Chaos Monkey for Spring Boot, actually comes in very handy if you do workshops about how to set up like distributed systems and systems who have to communicate with each other. And even like from a training perspective, it's actually a great thing to build that in, to simulate problems and then actually also dive into patterns, how to fix them afterwards. Beside that, I'm also lecturing at the Zürcher Fachhochschule für angewandte Wissenschaften, and I teach their courses about software engineering as well. So these kind of my topics, and that's why also I thought it's a great idea to talk with you about chaos engineering. So my presentation will be built on the 4 phases. First, like an introduction, what is chaos engineering and what is the problems and like the general problems actually we have when we're building systems. Then actually the introduction, why there is something like this. And then actually we dive into Spring Boot and applying the Chaos Monkey for our Spring Boot apps. Today, I actually won't do anything like live coding and so on, because I saw like in the previous session that the gods of the demos are not with us. So I thought it's better actually to show you some examples actually on the slides. And yeah. And then at the end, some ideas when you start with chaos engineering you have to consider. But before we get into this, there is a disclaimer. Warning, when talking to your manager, never call it chaos engineering. Call it resilience engineering or use another term. Humans do not like chaos at all. And this is something you should really keep in mind. We as technical persons, we love to actually talk about chaos. It's something fascinating for us and so on. But actually, when you talk about chaos engineering to managers, they would say, "Oh, that's something we actually don't know. It's archaic. It's something unpredictable," and that actually leads to fears, right? And humans really do not like chaos. We want to have predictive systems. So humans are actually central to both the problem and the solution of incidents in engineering. So that means like when you're building an application, you probably built the problem, but you're going to fix it yourself, right? And that's why we actually dive into first the thing where we talk about the problems which might happen in production and then take it from there. So, well, incidents or even like incidents management. What could actually happen in production? Well, there might be an availability drop of some services, or we got some features broken, there is an issue with the application, we lose data, and there are some security vulnerabilities. And we all know all these big stories of big things like fat finger problem or something where like a whole site was taken down and like something was not working for hours at all. We definitely know about that because that's something we usually see about our industry in the media. And that's something which is not really good because people not familiar with IT, they always think, oh, it might be a virus or there is a hacker attack or something. And the good news are never shown in the media. But actually, these are the things which happen to our application and we have to deal with them. So if you come up with an incident management, you might come up with an idea to categorize them. And there are actually severity incidence levels where you could like put your incident into a specific category, and then you would actually say like what or how you need to tackle this. And as you can see, not all severities are the same. There might be different levels from like a high severity impact to a critical service impact, even a catastrophic service impact. And that means also like the solution time to recover is different, because if it's just a high service impact, then it might take a day, for example, and it's still good enough, right? And then actually other services you need to resolve like in hours, or our catastrophic ones, yes, like within 15 minutes. And if you think of a payment system actually, which is not available and people cannot do their Christmas shopping, it's actually severe and we have to deal with that, right? So that means also like there are different persons who are notified and also who could like informed about these issues. And just keeping it on your side and trying to fix it yourself and being a hero is probably not a good idea. So you could actually go and categorize it. So if you read about this incident management thing, you would come up with this, right? Then actually also there is a severity life cycle where you try to find out about the issue, the diagnosis, the mitigation, and we go over to like prevent further issues or future issues, and we try even to set up like alerting or paging on those things. Typically, we have special ratios, as you can see, like time to detect or total time of impact, then also like time to recovery and all these kind of things. So I wanted just to give you like an example so that you could see that these things are usually managed in a good way if you do a proper setup. And probably like in a bigger enterprise, people are doing it like this, calculating numbers. And actually what you could do is you could calculate the numbers, because like one calculation could be the percentage of loss of requests, and then actually also multiplied by the time of the outage. And you can imagine if you have the percentage of loss and multiplied by a time, you get a factor, which easily helps you for high severity impacts to organize this or to prioritize this. And then actually you know what you have to fix first. So just giving you an idea here, what could go wrong and how you could measure those things in production. Now I want to go a step further, because also to this, there comes an idea which comes also from organizational theory. It's called resilience engineering. And I used the term already before, and that's why I want to point out to this. So if a system or an organization is really resilient, it follows the 4 ideas. So that means like we have to respond to events. And that kind of means like if something happens, we fix it, right? Then actually to respond, it's important that we can actually detect those issues. So we need to monitor those things, right? Otherwise, we cannot actually respond. So monitoring is even more important than just like responding, because when you see things coming, it's maybe a good idea, right? And that goes to the next point where we discuss like anticipation of future threats and opportunities. And that means like we kind of predict what could happen in the future, and we see, for example, other services failing, and we know, for example, if other services are failing in our system, then actually our application might fail as well sooner or later. And then obviously a very important thing at the end, it's actually learning from the past failure. And that's why so many companies, and especially like the big tech companies, they write a postmortem about what happened exactly, like really with timings that they can learn from this, and that they can actually like improve their practices. So they understand exactly what's going on. So even like postmortem and then learn from this is an important thing as well. So these are just like the essential abilities of resilience. Now you can imagine, question would be like, how do you actually do this in your company, even if you don't talk about the technical topics? And an idea could be actually like training the teams. How do you train a team? What do you want to achieve with this? And the idea in generally, to like summarize all the points I have on this slide, is that you get used to that something will go wrong in production, you know, and therefore you're not stressed. You don't make mistakes because something is going wrong in production. It's like a situation which just like happens all the time, and you can have a clear mind, go through your checklist, make a good decision actually in this specific situation, and just like fix it, right? But if everyone's like running around or like behaving like bees and just like, yeah, being in a swarm and nobody knows what to do, it's really critical probably for your service, for your product, for your whole company. So especially as well, if you just maybe have like a fat finger problem and one whole side goes down. So the idea of this is basically training the teams where like all the human factors are coming in. And the human factors, as you can imagine, are about like, yes, we want to make it easy for you, or even like for Homer Simpson, to do the things right. At that point in time, when you see there is like a warning sign, there is something like the dashboard blinking and whatever, you just want to do the right thing. Well, maybe you don't know right now what's the right thing, but probably there is like a scenario where we maybe can like do some fallback of a system, or maybe we can like shut some parts down and like think about it clearly, whatever. There might be some checklists all helping you with those things. You can imagine if you're flying as a pilot, you would still like follow the procedure. This makes things easier, right? But we humans, we are usually like one of the problems when it comes to disaster. Now, let's say when you want to train engineers, or when you want to train like the team, what could you do? Like there is a thing which is called game day. Like big companies like Amazon, Netflix, or Google, and so on, they are doing a day where they try to like simulate certain scenarios, and the teams have to fix it, right? So it's kind of interactive real-world learning exercise where you try like to get used to these problems actually, right? And therefore, when these things happen afterwards in your daily business, then actually you're used to this. So Jesse Robbins created this idea of game day during his time at Amazon. And what I find personally very interesting when I read his bio, you can find it as well on Wikipedia, it's quite small. He was called, and it was even approved by his managers, the master of disaster. So that was his official title. And he came up with the idea of game day because he was responsible for all the pages, websites Amazon was having, which were branded by Amazon, that those things actually like get better and resilient. So if something goes down, well, we can fix this. I heard like once a story, I'm not sure if it's a rumor, that he just went like occasionally through the data center and was pulling cables at the beginning. And then actually the engineers had to basically like find the issues in the network and like recover from that disaster. And you can imagine if this happens like regularly, you get used to it, you find approaches, you implement approaches that you can deal with those things. So that's actually the idea behind. So training your team, because we humans, we need to get used to it. Now let's jump to chaos engineering. And what is actually chaos engineering about? So chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. So this is the definition of chaos engineering as you can find it on the website of Principles of Chaos. So but what does that mean actually? So the idea definitely here is we want to get used to this, right? So chaos engineering is a part to build resilient systems. And it helps us basically to understand what could happen to our system, what could be fixed so it does not happen. And then actually that we have, and we always will have these turbulent conditions in production where we don't know that services are coming and going. We have probably users with a wrong app, which like enter wrong data and this kind of things. So actually that our application is not failing, right? So we try to get rid of all the possibilities and want to make our system more resilient in the end. So the principles of chaos engineering, which are also mentioned on the same web page, are actually defining a process, how you would go through and like what could be the procedure, how you start with chaos engineering. The most important part is actually that you have an application which is up and running. And this is actually called the steady state. So you have a system which works, which shows normal behavior, and you have at least data you can measure so that you know the application is running properly. And then you're trying to make a hypothesis because you want to know what's the experiment you're going to do, right? So that means like you are going to define an experiment and maybe not just like on all the instances at the same time, but maybe you have a control group where you have measurements and you have also an experimental group. These days, when we have like multiple instances of an application, that might be quite easy to do the setup and to like split the load and compare things. So like if you maybe do A/B testing and other practices, right? And you come up with the ideas like what you could change in the system. Then you introduce variables that reflect the real world events, like servers are crashing, hard drives are not working, networks goes down, latency, this kind of things. And you try then to simulate this in the system. We try actually to disprove with this the hypothesis we defined in the previous step, right? So that means like we're trying to find out, or we try to prove that the application will still work in a normal behavior. So without making these experiments and define them in a proper way, and just like running around and like pulling just like some cables out of the servers, that's probably not a good idea, right? Now, you could say, well, maybe when you talk about this chaos engineering, isn't it just like stress testing? Well, that's really like the question. I don't think so, because stress testing just adds more load. That might be just like one variable of the whole system. But you have to imagine that everything will fail all the time. And this is just like a quote from Werner Vogels, the CTO of AWS. And I mean, it's maybe not this disastrous, but you can assume that something will fail all the time. And therefore, we just like can imagine actually what that could be, right? So typical sources of failures are application is not running. We have an issue in the container or the container platform. We have like databases and services which are not working. We have like operating systems which are the problem. Then we have hardware involved, right? We might even have network and whole data centers involved. So like we have lots of variables, and as long as we are going to add additional abstraction layers, it just gets weird. Now, what I would love to do right now is like, where does the practice of the chaos engineering comes in? And you probably know, like from the whole agile movement, that people like to use the Kinefin framework to explain things. And I also would love to use it to show you actually where we would have to place chaos engineering as a practice. So I'm not going to explain the Kinefin framework because probably you know this already, or otherwise please look that up. What I want to show you is here that you might say chaos engineering maybe comes from the chaotic zone, right? And probably with this chaos engineering, we try to move into the complex zone. And I can tell you that's not true. And actually, that's great that it's not like this, because as I said at the beginning, chaotic chaos, nobody likes this, right? So what we are going to do is actually, when we have a complex system, as we have usually like with software systems, we try to move it from complex to more complicated. So it's easier for us to understand and we can easier fix it, right? And we know that we need to do some learning in complex systems usually. And on the complicated thing, that's more like the area where we do engineering tasks. So we try to move actually our system we have more from the complex side to the complicated side. Now you could say, yes, microservices are on that end, but I also would say if you have self-contained systems or even monoliths which are using external services, they could be still on that side as well. And we just try to move it to the left side, right? Okay, so now actually there are plenty of chaos engineering tools, and there is an awesome repository which is called Awesome Chaos Engineering on GitHub, and you can find plenty of different tools here. So this is just a screenshot of what's there, but the list is quite huge, so it doesn't fit actually my slide. Just to tell you, when you want to get into it, when you want to like have books recommended or like practices, tools, videos, blog posts, whatever, and it's actually a good starting point, this awesome repository. So I have it also for further references then at the end of my slides. Now, I just picked one of the tools. And since I'm like very familiar with the Spring framework and Spring Boot as well, I would love to introduce you Chaos Monkey for Spring Boot. And as you can see, probably it was heavily inspired by the engineering team or by the chaos engineering at Netflix, which started very early. And some colleagues at Codecentric, especially Benjamin, was actually starting this project and was actually driving it forward. And I think he implemented it in a quite a nice way. And I will show you why I like the idea of the Chaos Monkey a little bit later, and how smart it was to use like Spring stuff underneath to basically do the chaos engineering. So thanks for them actually providing us this awesome framework. Now, jumping into this, actually, we have just to add a dependency, which is called Chaos Monkey Spring Boot. In the current version, it's version 2.2. And when we start our Spring Boot app, then actually we just like activate a profile, which is called Chaos Monkey. if you don't activate the profile, nothing will actually happen. And that's actually great, because that could actually mean you could ship the Chaos Monkey with your application, and then you have a dedicated instance you want to test maybe in your Kubernetes cluster, and you activate the profile and restart that instance. So that means like the dependency could sleep within your container you're shipping. Now, the Chaos Monkey actually has two concepts we will have a look at. One concept is called the watchers. And the watchers are attached basically to all these components. You probably know like the Spring annotations for components like controller, service, repository, REST controller, and so on. And what they will use underneath is actually Spring AOP to configure proxies which might trigger afterwards assaults. So that means actually, and we will see that later as well, we need to specify which kind of layer we want to tackle for simulating failure in our application. So that means like UI layer, service layer, repository layer, or like any other Spring bean we have in our application. So by default, you would have to specify the annotation so that it could pick things up. So these classes don't have to be component scanned, but they have to be Spring beans. So they are looking at the annotation when they are creating the Spring AOP proxy. But you could actually also like register other classes as well, which are Spring beans. Now, the assaults, there are like 5 of them currently. And one of the assaults we will see is, for example, the latency assaults. So you can inject into your application some latency. Or, for example, you can also inject exceptions to simulate some failure. Another one, which is quite interesting, is the app killer assault, which just randomly turns off the application. And that means like consuming applications would have to deal with that. So we'll just see that a little bit later in an example. Another one, which is quite special here, is the memory assault, which tries just to fill up the reserved memory and tries to break the application by having out of memory exception. And the last one is not really an assault, but it's actually an assault scheduler. That means like the memory and the app killer assault can be scheduled at a specific time. So you could run them like inside your application, right? But with a cron job-like expression. Okay, so we came across these concepts. Now, typically, when you look at the architecture of the Chaos Monkey for Spring Boot, we have our Spring Boot application, which contains like all these Spring components. And then we have explicit watchers for those Spring beans implemented. And then on the right side, we have these assaults which will actually like inject failure, right? As we already discussed. So we have like the two components, the watchers and the assaults. Now, when you go and define your Chaos Monkey in your Spring Boot app, there is actually an actuator endpoint. And you could define the actuator endpoint and you just turn it on. And then what you also have to do, this is really mandatory, that cannot be changed afterwards during runtime. You have to specify which watchers you want to tackle, right? So which watchers you want to turn on. And in my example, that's something I usually do, is just having access to this service watcher. So it just actually focuses on the service annotated Spring beans. And that means basically a proxy during the startup is wrapped around all the services, which is about then to execute the assaults, maybe or maybe not, depending on the assault configuration. So you would specify that inside your application properties. Now, actually, what you could do is you could also like turn it on in the application property. So Chaos Monkey enabled is something you could do and say just like Chaos Monkey is all the time on, but you don't have to, because via the actuator, you can actually enable or disable Chaos Monkey as well. So if you really point to one single instance, like in your Kubernetes cluster, then actually you just can use a request to turn this on and off and like force then the simulation. But what I wanted to show you here is there are some properties you can use, but also on the other hand, you can as well use actuator endpoints to turn things on and off and configure the things as well. Okay, so let's first see, before we dive into some examples, what could actually go wrong. So usually a service and the repository is within our application. And as you can see, there might be some network connection, or maybe the database is failing, something like this, right? And now what actually the Spring Boot Chaos Monkey does, it's adding a proxy around the service as I have configured it on the slide. And then actually it might inject latency or an exception, a runtime exception into the whole thing. So what we don't have to do, as we see on this previous slide, if you want to simulate failure, we don't have to take down the database or like make the database somewhat flaky or the network flaky in between. Because the question would be, how can I make like 10 out of 100 requests failing against this database service? It's quite challenging. No, what we actually do is we introduce the failure already in the order service, so in the service level, and we just actually like throw an exception there or add the latency. A very good way to simulate this. And I think that's kind of smart, because you don't have to think of infrastructure and you can simulate in production easy issues with your environment or with your services you're consuming. Now, how can you simulate these issues? How would you challenge the Chaos Monkey, or how would you trigger it to actually run some failures? Now, I just made some examples with curl, so we can have a look at this. And what we do is here, we do a post with a JSON document, and we are sending to the assaults something where we say we want to have the exceptions enabled. So you see exceptions active is set to true. So this means actually that depending on how many samples we want to have with exceptions, the exceptions will be injected automatically. So you can easily throw a runtime exception with some message that it's from our friend, actually from the Chaos Monkey. But what you also can do is you could actually specify what type of exception it would be. But since actually in Spring, lots of things are anyway a runtime exception, that's actually a very good default. Another thing is you could say, I want to kill the end. I want to say just like kill application active. I set it to true, and then actually it will fail one point in time. Random point, obviously, and then the JVM is gone. So the whole application might fail. That's an easy thing I just can apply to my service. So let's hope that the clients or the consumers of this service can deal with that. There is another thing, for example, you could say it might take forever. So let's like piling up all the requests. And let's set the time, for example, here to 100 seconds, so that actually all the threads are gone in our Spring Boot application. So what I also specified this time is actually the level. How many requests will be actually attacked? And if I set level 1, that means every single request will be attacked. So that means like every single request longs at least 100 seconds. Now the level is actually the thing where you can say how many requests will be attacked. So there is a possibility to say, for example, 10, level 10, which would mean every 10th request would be tackled, for example. So you can actually specify via the level how often this actually happens. So here you see, basically with this kind of parameters you're passing, you can simulate this. Now, when we look at the microservice architecture, which you might come up with, I placed like the browser on the left side. I have like an API gateway in the middle, and then we have like several services which are then dealing with their own database. As we would say, that's a perfect microservice architecture. As soon as everything is fine, there is no issues in the network, right? But now actually, what would you do to basically simulate issues with a database service on the backend? Now, when we actually add Chaos Monkey for Spring Boot, we'll have actually here a proxy around our service instance in the Spring Boot app, and we might introduce here latency or an exception or whatever, right? Or we can also make, for example, that the application is actually failing. So we can easily simulate this, and that means in the end, the API gateway would have to deal with that. And that's then like, or the API gateway actually could be also another application which is just consuming those services, right? So this thing there has to deal with that. And usually when you think of that, the API gateway aggregates data from 2 or 3 of the services and just expose that to the single page application, we need to deal here with a failing service. And typically, and that's something where you then go and try to fix things, is actually that you add libraries like Hystrix or Resilience for J in that place, which then consumes these failures from the downstream services. So that means actually the API gateway would now be changed to deal with failing services, because typically in this situation, if we have a lot of latency, we might get a timeout, for example. We might get the 500 status code back, or maybe even the time actually just takes too long. And that would mean we don't want to block the request response connection on the gateway, right? So there are usually with these libraries many ways to fix the different issues. So I just wanted to tell you here, Chaos Monkey is one thing, but on the other side, we need as well approaches how we can tackle those problems. And the Chaos Monkey just helps us to simulate things. Perfect. So now, what is great about the Chaos Monkey, and in combination with the Spring Boot actuator, it's not only that we have the endpoints where we can configure our assaults, but it's also that we get metrics, and we can actually visualize this easily on a dashboard. And I just added a few metrics keys so that you could see that, for example, we have total request count, but also then total count assaulted. That's something we can actually visualize in a dashboard. Or we could see like how many things were failing because of the Chaos Monkey in our application. So this is basically helping us doing monitoring, and we know like what was injected by the tool. So we could know, for example, that a few requests could deal with that, and then afterwards others were failing, or we get like this ratio, how much our application was resilient compared to like the failing part, right? So like measuring things. Now, how would you start with chaos engineering? And this is now like getting to a few ideas at the end of the presentation. So like one thing is definitely, and that's also something like everyone who does chaos engineering says, be social and communicative. Talk to your colleagues that you're doing chaos engineering in your staging environment or in production. Tell them that things are going wrong so they know it's under control. and that you can switch back afterwards to a normal situation again. So it's really important that everyone knows this and it's like visible to them and they just like are informed that something is going on. Another thing which is quite important is actually implement monitoring, because if you cannot measure, you shouldn't start with chaos engineering at all. So having a good idea about how your application by default behaves in production or like in your staging environment is actually a good thing. So you can measure like the time before and afterwards, and you can compare actually what's going on, right? Then also another thing which is very important, which is called define your blast radius. So you don't want to have a nuclear bomb in your system, right? So you don't want to like kill the whole site or your availability zone. Define your experiment. Define like your blast radius so you don't destroy things. Just like do not like try to take down everything at the beginning, and still make sure that your customers can deal with your services, they can interact with, and so on. And especially if you do things where your system has to be up 24/7 and is not allowed to have zero downtime, this is actually like something which might be dangerous, like if the blast radius is too big and you have the situation not under control. And then actually, my last hint I would love to provide is that don't start in production. Even that production might be the nicest and happiest place on earth, as Josh Long usually says, don't start there, because you need to get familiar with the whole thing, right? And therefore, try to make experiments. Maybe try them first, like locally, go to an integration or staging environment, gain there some knowledge about the system, how it might behave, about your experiments and so on, and just don't start in production, because that really might hurt your business, right? So with that, I would love to like conclude my session, and I hope you had fun and you got an idea about chaos engineering, and that you easily could start with that using Spring Boot, because especially certain things like the infrastructure you sometimes do not have under control, or maybe you need other tools to like simulate issues in your Kubernetes cluster or maybe on the network and so on. But if you want to like simulate certain issues within your application, it's actually the perfect start. And as I also showed you, I think it's really smart implemented with the proxies in Spring. And also I think it's really nice done with the injection of the latency and the exception just like at the right place, because you don't have to simulate flaky services. Great, I'm done. So do you have some questions I could answer? So the question is, why perform experiments with chaos engineering in production? Isn't testing resilience and fault tolerance in staging dev environments enough? Well, if you go that step forward, like Netflix does, or like huge enterprises which provide services you're consuming every day, you can imagine that they don't have a proper test environment. Certain companies are not even having test environment because they are doing continuous delivery or even continuous deployment to production and using feature toggles. So now the question is, if you don't have a test environment, how could you do this, right? And then the other question would be, how can you simulate actually an environment which is very similar to production? There are tools where you can like shadow copy requests and like send them to another system where you could do the experiments on. So you would have like a dedicated environment to do some, as you say, chaos engineering this, but this means actually you need additional hardware. And actually, since the production environment and the staging environments are usually not the same, and you don't have the same load and like other parameters, there are companies which force their team actually to do the right thing. And the right thing here definitely means force them actually to be aware of that things can go wrong. And they would have to prepare themselves with tests, like with chaos engineering. And then actually, like at Netflix, you have like the monkeys going around killing processes, servers, and even data centers like once a day, and being not reachable for services, right, which would consume those maybe on a particular site. And that means actually your applications are forced to implement the things that you have failover, that you can deal with data which is not available because maybe you're using caching, or you're using like patterns for retry, or like, let's say, you're forced to do messaging when you have a business domain where asynchronous messaging is good and it works there, right? So that means like you're just kind of forcing the team to like really think of what could go wrong, and then you have PagerDuty as a team for your services, and then you try to make sure that your application behaves in every case well in production. So this is just like maybe to add more motivation, as I would say. Cool, great. Thanks a lot for your question. But that means just like you're adding additional pressure on the software development team and everyone else, but that means you need to come up with some ideas. So the question, like, do you gain experience in automating chaos experiments? I don't have myself experience in automating chaos experiments. So what we did in several projects was actually using the tool, and we were like doing really like on a dedicated purpose. We defined ourselves the experiments, and then actually we tried to simulate that. And what I didn't tell you actually, like on the previous slides, obviously you would have to generate some load on the system, right, with chaos engineering. So if you run things in a test environment, you might need a load generator. You might use something like Gatling, JMeter, Blaze meter, or whatever. And yeah, so you need enough load. And then automating this, I'm not sure if this is a good idea, because you don't have like changing experiments, because you have changing experiments. They don't stay the same. If you have implemented Hystrix or Resilience for J, then actually your experience might be different afterwards, right? So do you know how active the project is? Last release is from January, and for Spring Boot 2.1. Well, you can say that the project is not super active, but there is still a team at Cocentric which maintains things. I don't think you can actually add now too much features to it, so it's kind of feature complete. And I think actually it shouldn't be a problem to do it with the current Spring Boot versions. I'm not sure if this release for Spring Boot 2.1 is really the last one, because I definitely used it for Spring Boot 2.2 for sure, and it should also work like with new versions. If you know others, how do you compare to other frameworks? What's missing in this one? I cannot compare too much to others because I'm not like working with tools on the infrastructure side. I'm more like on the application side doing this. So not much comparison possibilities here. So the only thing what I see is actually that we try to simulate things within the application, and we just use like the Spring possibilities we have. So you definitely have some limitations because of this. So you cannot really define, for example, wrong messages which are coming in from a database service, or like wrong communication protocols because of a bit flip or whatever. So we are really trying to inject issues on the application level, and we assume that if the communication would go well, yeah, it would be fine. So I think we have definitely a limitation on the application level. And again, the question which is related to automated chaos experiments. When you would talk about automated chaos experiments, I think it's more like you're doing load testing. And this is not the same, but you can imagine, well, in your build pipeline, that's also a good question, because would you deploy that afterwards somewhere so that you are consuming other things? So I think we would have to see how the whole system is set up, and like your deployment infrastructure. And yeah, I'm not sure. I mean, definitely you can automate this, you can script things, and you can make things easier, definitely. You can create a wrapper around the curl commands and just like do things like this. Yeah. But I guess then you also have to think of like the load and everything else. So thank you very much for your time. Enjoy the JCON. Thank you very much.